So put today's date at the top of your paper. Put 2/12, since we are technically doing these notes for class on February 12th. Fill in your page number. And we are on section 11-3, slope and y-intercept. Slope gives you the steepness of a line. The higher the number, the steeper the line. We've talked a little bit about slope so far. And we talked about it being the rise over run, and we talked about the types of slope, which we're going to review. The second definition we have is a y-intercept, and the y-intercept is where the line crosses the y-axis and we're talking specifically about the y-coordinate at that point. And we call this letter B. So in an ordered pair, when we're talking about the y-intercept, the first coordinate is going to be 0, and the second coordinate is going to be B, and that is our y-intercept specifically. So now we move down the line, and now we're talking about the 4 types of slope again. And if you recall, when you're looking at a line from left to right and it's going uphill, we're talking about a positive slope. If you're looking at a line going downhill from left to right, you're talking about a negative slope. And if you have a line that's horizontal, you're specifically talking a slope of 0. There's no rise involved, so our m is equal to 0. A vertical line is kind of like you've fallen off of a cliff and there is no slope because the rise is so high, but there is no run. And in a fraction, we can't have a denominator of 0. So we just say no slope, or it's undefined slope. And moving on down the line, we come to the slope formula and examples in finding the slope with the formula. We have the change in y over the change in x, and we have the formula y2 minus y1 equals x2 minus x1. And so for our first example that we have here, we have the ordered pairs 0, 3, and 2, 0. And the ordered pairs always go in the order of x, y, and xy. And I usually just start with the first ordered pair as my x1, y1, and my x2, y2. But you can flip-flop them. You don't have to be picky about that. And so we have m equals our y2, which is 0, minus our y1, which is 3, over our x2, which is 2, minus our x1, which is 0. This simplifies to a negative 3 over 2. The second ordered pairs of examples that we have here are negative 2, negative 1, and 4, 3. So if you want to, you can go ahead and label them x1, y1, and x2, y2. And so I start off with m equals y2, which is 3, minus y1, which is a negative 1. So you have a double negative here that's going to cancel out. Put that as a fit and just show you that we're adding now. On the bottom we have x2, which is 4, minus x1, which is a negative 2. Same kind of thing with the double negative. They cancel each other out and we've got positives. Simplify this, and we have 3 plus 1 on the top, which is 4. 4 plus 2 on the bottom, which is 6. This reduces to 2/3. So we would have a rise of 2 and a run of 3. In the third example, go back, we have the ordered pairs 2, 1, and 2, negative 2. So we have m equals a negative 2 minus 1 and 2 minus 2, which gives us a 0 on the bottom. And like I said before, we can't have a 0 in the denominator because that means the fraction is undefined. So the slope for this one is no slope or undefined. And that means that we have a vertical line if we were to graph these 2 points.